All right, we're going to write an algorithm that will find the target number in an array that has the condition where every member is just one away from its neighbor. So let's say we have 8, 7, 6, 7, 6, 5, 4, 5, 4, 3, 2, 3. So you can see that each neighbor is only one away from its next door. So what you can do pretty easily is we'll label these two. Is that for any given number, if we're looking for a certain target, then there's a minimum distance away that that's going to have to be from it in theory, given that they're all one apart. So say we were actually looking for the number 5 and we started at the 8 here, we could see that we know that, 5 is a difference of 3 from 8. So theoretically, the absolute closest that the 5 could be is 3 away, because let's pretend that it went 8, 7, 6, and instead of this 7, that was a 5, which is very possible within the guidelines of the array. Um, then you could see that 1, 2, 3 away is the closest it could be. But in this case, it's not. But what we can do is use that information to kind of skip certain amounts. And then when we skip it, we can go, 8, 7, 6, 7. So we would end up here. And then we would say, okay, 5 and 7 are 2 away from each other. And you can see quite easily that you get to the 5 from jumping 2 more. So you just recalculate every time you move positions. Okay, so in order to do that, it's actually a pretty simple algorithm. We're just going to write it here. And we're going to have it return the index that it's found at. Let's just call it find the number, and it's going to take in an array of ints. And it's also going to take in the target that we're looking for. Okay, we'll just have a counter that's going to change its value according to the value that it lands on. So you can start that at position 0. And all we have to do is say while count is less than array.length, then that's where we're going to do our steps. So first we'll put in a little text if count equals, nope, sorry, if our count equals our target. So not if array at count equals target, then we can return count because we're returning the index. Otherwise, what we want to do is say count, we want to calculate the amount we're going to skip. So count plus equals array at count minus target. And we get out of that. If we don't ever find the target and we go through the entire array, then we're going to just return -1, indicating we didn't find it since that isn't a valid index. Okay, so let's walk through this code, and obviously we would want to probably put a little test in here, if array is null, I should say equals 0, or if it's null, we'd have like a whole test in here, return -1 or something like that. So let's walk through here and see. Let's go ahead and make our target equal to 2. Okay, so we'll say target is 2 and count is at 0. We'll just keep track of count over here on the side, starts at 0 because our array is not empty. And then so while count is less than array.length and the array length is 11, So, or I should say it's actually 12 because there's 12 elements in there. And then, all right, so that condition is true. So if array at count equals target, so here we're at this one here, and that does not equal 2. So that does not hold true. So count plus equals array at count minus target. So we're at 8 minus 2, which is 6. So now count is 6. So you're going to see that we get to jump a large amount to kind of skip over. So then we go back around. Count is still less than array.length. So we go in, and if array at count, which is array at 6, and if that equals target, which it does not, then count plus equals array at count minus target. So 4 minus 2 is 2. So we add that to count, and it's now 8. We go around, 8 is less than 12. So if array at count equals target, array at 8 does not equal target, it's still 4. And so we go in, count plus equals array at count minus target. So that means count is going to add 2 to it. So now count is equal to 10. So we go back around, 10 is less than 12. If array at count equals target, return count, and we look and we see that counts at 10. So we're here, and array at count does equal 2. 2 is equal to our target of 2. So we're going to return count, which is index 10, is what we're going to return. And then we get out of our function, or it's going to kick us out of our function. So we can see quite easily that you can maneuver through these lists pretty quickly by being able to jump through certain elements. And this is worst case in O of N solution, because even though we're getting to jump through, theoretically, you could have a situation where you keep going through each element because of the differences in your targets and things. So that is the probably most efficient way that you can do this.